Hello and welcome to this M1 mechanics video on the kinematics of a particle moving in a straight line. This is also known as the SUVAT equations. Okay, these epic little equations are very useful, and by the end of this video hopefully you will want to get these equations tattooed inside your eyelids, ready for your mechanics exam. So the basic idea is you've got 5 different quantities. You've got an S for displacement. Don't ask me why it's S, it just is. U for initial velocity. V for final velocity. And these are quite nice because U and V are next to each other in the alphabet, and U comes before V, which is suitable because it's initial. You've also got A for acceleration, quite logical, and T for time, again, logical. Now the conditions of the SUVAT equation are that there is a constant acceleration, and that's about the only conditions. There's some others, but that's the big one, okay? Because it's a displacement, and displacement is a vector quantity, the particles usually move in a straight line. And by usually, I mean always, and that's pretty much it. So, let's have a look at these equations. The first two we're going to look at are pretty simple, and you'll have seen them before if you've ever done any level of Key Stage 3 science. And the first one is for acceleration, where acceleration is defined as a change in velocity over time. So change in velocity is your final velocity minus your initial velocity. Okay? How much is it different? How much is it changed by? Well, what was it at the start compared to what is it now? The final, take away the initial, is the comparison. Divided by time, divided by t. And that's your acceleration. Now you can rearrange it. You can take the t up to the a, you can multiply both sides by t, and you get v minus u equals at. And you can then rearrange a little bit more to get rid of this minus u, just to make it a little bit more pretty. And what you end up with is this equation with no s terms. If you look at the equation, there's no s. Okay, now the original 5 values that we were looking at, or 5 variables, s, or displacement, was one of them, and we now don't have displacement. Okay, so forgive me if the fan on my computer is now screaming into the microphone. So, moving on, we've got distance moved is your average speed multiplied by your time. So the distance moved is the displacement, okay? This is a very basic equation. Moving it forward, we can define the displacement rather than the distance moved. And remember, distance is a scalar and displacement is a vector. And rather than average speed, we can use the vector quantities of velocity. So the average velocity for a constantly accelerating body will be u plus v over 2. Okay, so initial plus final, add them together, divide by 2, you get an average. Simple enough. Multiplied by time, happy days, this equation has no a term in it. Why is no a term useful? Because sometimes you might not know or care about acceleration. So, we move on. Now with those 2 basic equations, you can get the rest of your equations, and all of these equations will have one of the particular variables missing. So now to get rid of t, you just take the 2 previous formulae, you take a is v minus u over t. Acceleration is changing velocity over time. You rearrange it, and you take displacement is average velocity multiplied by time, and you combine those. Now in combining you get something like this, okay, and this 2 and this a can be multiplied. You can multiply both sides by a 2a, which gets rid of these, so you get 2as is equal to u plus v multiplied by v minus u. Now the two v's, when they multiply, if you notice, the plus and the minus are going to cancel some of the cross multiples, and so you're going to get v and v both positive multiplying to give us a positive v squared, and u multiplied by minus u is going to give us a minus u squared. So 2as is equal to v squared minus u squared, which again can be rearranged to get rid of a nasty minus. Nobody likes minuses. So you get v squared equals u squared plus 2as. So, new equation. You say bye bye v. Say bye bye. So, if we take v is equal to u plus at, and you may be thinking, I think I've seen that equation before, and that's because you have. And you put that equation into s is equal to u plus v over 2 multiplied by t. You get this equation here, okay? So you have u plus u plus at, okay? So this is u plus v, only the v comes from here now, over 2 multiplied by t, and then you simply work it through, okay? So you've got 2 u's, the at, both over 2 multiplied by t. The 2 here will cancel, you get u, get a half at, it's all multiplied by t. So let's expand. S is equal to ut plus half at squared. So you now want to get rid of u. Okay, so we take that equation that we had earlier. S is equal to ut plus half at squared, that one from the previous slide, and we replace u with a v minus at. We substitute that in, and we have s is equal to vt minus half at squared. Okay, happy days. You've now got 5 formulae, all with a little something missing. Okay, so forgive my laptop, it's now going to say you have no s term here. This term here has no a. This term here has no t. This term has no v. This one has no u. Why is that important? Because in each of the equations you will have a piece of information that is missing. Each situation you will have 3 known variables, and a 4th that you'll have to find out, and a 5th that you won't care about. So let's just make this look like an S, not a 5. You use the formulae to find your 4th variable, and you pick your formula based on what you don't care about. Okay? So in the next video we're going to actually look at the application of that. For now, all you really care about is where those formula came from. Okay? Learn them. The best way to learn them is going to be to use them. You're going to want to do about 1 million examples of different questions involving each of these. Okay? So do it, and try it. I've tried to go through the video and the explanation and derivations as slow as possible, but if that's not slow enough, have a look through the video again, okay, and again until you think you get it, okay. I've also got another video which goes through the derivations but derived graphically, which I'll post on my channel as well. And the next video in the channel will be to do with how you derive or how you use the equations, okay? How you get to that fourth piece of information using one of the 5 equations. Hopefully this is useful. Thank you for watching. Bye.